Hey everyone, so today we're going to be going over graphing log and exponential functions, including their transformations. What happens when the base is a fraction essentially, so between 0 and 1. Also, how to graph without a calculator using only the parent points and the transformation rules. So first, let's look at the difference between an exponential function and a log function. All right, so here we have our exponential function and our log function. And as you see, like I put base here in green because that's going to change for any time, for any of your graphs. Okay, you could have log base 2, or this could be 2 to the power of x. That will always change, but these things will remain consistent no matter what your base is. All right, so first, our y-intercept is 0, 1. Our domain is all real numbers. Range is 0 to positive infinity. Horizontal asymptote at y equals 0. And you'll notice if you go left to right on the domain, it's always increasing. Okay, now let's look at our log function. So log whatever the base is of x. So it's going to come close here and then shoot up that way. X-intercept is 1, 0. Domain is 0 to positive infinity. Range is all real numbers. Vertical asymptote at x equals 0. And yes, even though the domain doesn't go over here, but if you go from the domain across, starting left to right, it still is increasing always. Now, what you'll notice is that these are actually inverses of each other. Okay, which means they are reflections across the y equals x line. Okay, and if you notice, our y-intercept was 0, 1. Again, remember when we were doing inverses, you just flip the x and y. X-intercept is 1, 0. Domain is all real numbers. Range is all real numbers. Okay, same here, same here. Horizontal asymptote, vertical asymptote. Now let's talk about the transformations. All right, so here are the transformations for exponential and log functions. They're exactly the same rules as we had for our parent functions, and they all apply the exact same way. So starting with k, both k's, okay, it controls up or down movement, and it's exactly as is. Our h here is right or left movement, but remember, if something is with the x, it's going to be opposite of what you think. So if it's negative, go right. If it's positive, go left, okay? The b tells us horizontal stretch if the absolute value of b is between 0 and 1, and a compress if the absolute value of b is greater than 1, okay? Again, opposite of what you think. If this is negative out in front of the b, you're going to flip it over the y-axis. The a out in front here and the a out in front here tells us vertical stretch if the absolute value of a is greater than 1, or compress if a is between 0 and 1. And if there's a negative out in front, it flips over the x-axis. And one special thing that we do need to talk about is if your base is between 0 and 1. Okay, so if the base is between 0 and 1, it's actually going to flip the graph over the axis that it already crosses, okay? So remember up here, our exponential graph crossed the the y-axis, and our log function crossed the x-axis. So here with our, oh, there we go. Here with these, so you'll see we flipped it over the y-axis, and we flipped this one over the x-axis. Yeah. So our y-intercept is still 0, 1. Our domain is still all real numbers. Range is still 0 to positive infinity. Horizontal asymptote at 0. The only thing that changes is now it's always decreasing. And you may recognize this from word problems that talk about exponential growth or exponential decay, okay? And this one, again, all the same aspects, except now again, it's always decreasing. Now, how do you graph without using a calculator? Now, one thing I do want to tell you, if you're in a pinch and you do need a calculator and you don't have one with you, go to wolframalpha.com. You can actually type it in there, and they even have math language now, and you can actually click on the log button and type in your base and your of number, so you don't have to do change of base on your graph. But anyway, that's just a good little thing if you're in a pinch and forgot your calculator somewhere. All right, but how to graph without a calculator. So first you're going to want to find your parent points. Okay, and looking back to when we had all of our parent functions, these are what I mean by parent points. So you've got -1, -1, 0, 0, 1, 1. Okay, and then going down to, this is one in particular that I'd like to talk about. So it's the square root function. So anything you want to put in here, you want to be able to easily take the square root of. So that's why our points are 0, 0, 1, 1, and then it jumps to 4, 2, because you can easily take the square root of 4, okay? And then the other one that I haven't gone over is this function. These are your domains. This is your range. You have a vertical asymptote at 0, and you have a horizontal asymptote at 0. And your parent points are -2, -1/2, -1, -1, and then -1/2, -2. And then on the other side, it's just flipped. So it's +1/2, +2, 1, 1, and then 2, 1/2. Those are the only ones that I didn't really get into on the other one. But for these functions, your parent points are largely going to depend on the base. So if it's like base 2, obviously your parent points are going to be 0, 1, and then 2, and then 4, because 2 to the power of 1 is 2, 2 to the power of 2 is 4. But we'll go over an example here in a second. So let's just get through the rules. So first, find your parent points. Second, you're going to multiply your y values by the plus or minus a that was out in front. Okay, so the vertical stretch or shrink, and also if you're going to flip over the x-axis. But you're going to multiply your x values by plus or minus 1 over b. Okay, this is really important, because remember when we were talking about transformations, the horizontal stretch was if the b was between, the b was between 0 and 1, and the compress is if the b was greater than 1. So that's why we have to multiply by the reciprocal of 1 over b to the x values of our parent points. Okay, all right, number 3, you're going to add or subtract k to the y values and h to the x values. Because remember, k controls up or down, which is the y-axis. H controls right or left, which is the y-axis. And always remember, this is going to be opposite again. Okay, step 4, just check your points. Okay, our example for this is going to be y equals negative base 2 of -4x plus 20 and minus 3. Okay, so the first thing, our base is 2. Okay, so first thing we need to do is get our parent points. Actually, no, the first thing we need to do is get this x by itself. Okay, so we're going to factor out the -4. So 20 divided by -4, -5. Okay, now we can do our parent points. Okay, so since our parent function is 2 to the power of x, right? So we'll plug in 0, we get 1. Plug in 1, we get 2. And plug in 2, we get 4. All right. And our first step is to multiply the y values by the value of plus minus a and the x values by plus minus 1 over b. Okay. So this is going to be x times negative 1/4 and y times negative 1. So we have 0, 1 times negative 1/4, and 2 times negative 1/4. Okay, y's times negative 1, negative 1, negative 2, negative 4. Okay, our next step is to add or subtract k to the y values and h to the x values. So here our h is negative 5, but we know it's going to be opposite, so this is going to be x plus 5, and our y is k is negative 3, so y minus 3. So 0 plus 5 would be 5. Negative 1/4 plus 5, 4.75. And negative 1/2 plus 5, 4.5. And now our y values, negative 1 minus 3, negative 4. Negative 2 minus 3, negative 5. Negative 4 minus 3, negative 7. Okay, then we go to graph it. Okay, so we have 5, negative 4, 4.7. Oh, this is going to be really tight. And then 5, 1, 2, 3, 4, 5, 6, 7. Okay. Okay. Now the biggest thing we do need to address is where the horizontal or vertical asymptote is, right? So even though we have flipped it over the x-axis and the y-axis, we're still going to have a horizontal asymptote, okay? And where is that actually? Well, it is controlled by this value, okay? So since our horizontal asymptote starts at 0, if we move the graph down 3, our horizontal asymptote is going to be y equals negative 3. And same thing goes for the log function with the vertical asymptote, except that vertical asymptote is going to be controlled by this value, the h value, right? And so if it says negative 5, we know that in the log function, obviously. If it's x minus 5, then we know that our vertical asymptote is going to be x equals positive 5. Okay, that's it. Thanks for watching. Let me know if you have any other questions. And thanks so much for your support, guys. Have a good one.